this video we are going to go over the notes on probabilities involving areas, and I will try to keep things short and sweet. This is pretty simple. Just like any other probability situation, we are going to take the whole as our denominator, and we're going to find the part that we're interested in as a numerator, and then we are going to do division, get a percentage or a decimal, and call it a day. So we've got this example here. It is a circle inscribed inside of a square, and we want to know the probability that if we were to pick any random point, a point in the white area, a point inside the circle, we want to be able to answer questions about the probability that the point would land inside the circle or the point would land outside the circle if we were to just pick any random point inside the square. So the first thing we need to do is we find the area of the square, and that's pretty easy because the square is 10 units long. So the area of the square is 10 squared for 100. And then we would also need to find the area of the circle. So the circle has a diameter of 10 because it has it's inscribed inside of the square. So a diameter of 10 means a radius of 5. So the area of the circle is pi times the radius squared, and that is 25 pi, or we can go to a calculator and get a decimal equivalent. 25 pi is about 78.54, so we will just say that is about 78.54. And now we just take the ratio of the two areas. We have the empty space, or the area of the entire square, that's the whole. So we'll do square as our denominator, or rather the area of the square, and then the area of the circle will be our numerator, and plug in the numbers and we're good to go. I made things simple on purpose. The square is 100, and so that should give us a nice percentage. So we'll just take this number divided by 100. So the percent of the square that is covered is about 78.54%. Or the probability of picking a random point inside the circle is 78.54. And then we have this follow-up question, the probability of landing inside the square but not inside the circle. Well, if there's a 78.54% chance that I'm going to land inside the circle, then we just take 1 and subtract off the decimal value I just got, so that's the complement. So 1 minus 0.7853 is 0.2146. So there is a 21.46% chance that we would land in this white space here, any of these white spaces, and only and then a 78% chance that we would land in the shaded area. And that is it. That is all there is to do. You take the area of the whole and divide it by the part that you're interested in. So here's two more examples I'll do with you. The picture below represents a parking lot and a target inside that lot. If you toss a watermelon off the building blindfolded, how likely are you to hit the target? So this is our target. This is the whole parking lot. So we want the area of the entire parking lot, and that is the area of, that's just going to be length times width. So 30 times 80 is the area of the whole, and then 5 times 8 is the area of the part, or the shaded region, and then we just do the math. 5 times 8 is 40. 30 times 80 is, that's 2400, and then we divide. 40 divided by 2400 is very small. Multiply by 100 for a decimal, so that's about a 1.67% chance of hitting that target. And again, we can do the same thing with circles. The diagram represents a small fish tank. The fish inside swims around at random. What is the probability that the fish is in the outer ring? So we want the area of the entire circle for our denominator, and we can see the radius of the entire circle. This outer circle here is going to be, that's our whole, pi times the radius squared, so that's pi times 14 squared, and we can get a value for that in the calculator. And the numerator here is going to be a bit tricky, so let's go ahead and start 14 squared times pi, 196 pi, or about 1934.44. 1934.44. So that's the area of everything inside the circle, the outer circle, the shaded area and the empty area. So if we wanted to know the probability that the fish is in the outer ring, we could find the probability that the fish is in the inner ring and then just subtract from 1. So our smaller circle is pi times 7 squared. So we do 7 squared on the calculator, multiply by pi, and that's 153.94 about. Now what we've got here is the probability that the fish is in this center circle here, and we can go ahead and get a decimal there. We'll do this divided by this, so that's about a 7.96% chance. And then if there's a 7.96% chance that the fish is in this inner circle, 1 minus that value, or 100%, minus 7.96% is going to give us the probability that the fish is in the gray circle. So we'll just do, let's see, 1 minus, and then times 100. So there's about a 92.04% chance that the fish is swimming around in that outer circle. So this problem is perhaps a bit more complex than the first two, but the name of the game is just to calculate the area of the whole and use that as your denominator, and then calculate the area of the part you're looking for and use that as the numerator, and then that will give you the probability that you're looking for as a general rule. So try the practice problems on the next pages on your own.